Hi, and welcome to 7.3, the Unit Circle, Part 2. Last time we covered everything about the important angles, and we also derived sine and cosine of 45, 30, and 60 degrees. So now I'm just going to pick up where we left off, which is going to be finding the domain and range of sine and cosine functions. So the question we want to answer is essentially, what are the smallest and largest numbers that can be inputs of the functions? And yes, I said functions just like we were sitting in an algebra class, because sine and cosine are both functions. And maybe we have or we haven't thought about that before, but they are actually functions of just what we're trying to find here. So let me go ahead and get my pen going so we can find this. Okay, there we go. All right, so here we're given the unit circle again. You guys notice that we have these endpoints on our circle at these intersections. So this also gives us the boundaries for sine and cosine um, here. So let's just say, for example, we wanted to find the smallest number for, and we'll just start with cosine. So if you guys remember cosine of our angle, we can call that measurement t or x or theta. Um, we know that that number usually corresponds with the x coordinate. So if I wanted to go from the, say, the highest to the lowest, what would that look like? Well, what is the smallest x value that we can have on this picture, right? On this diagram. So the smallest x value would be -1. So that would tell me that my boundary for my domain, since domain corresponds with x, would be -1 to, so I'm using interval notation, and then now I need to find the largest input value, which would be 1. Now let's find the range. So the range will include all of our sine values. What are the smallest and largest inputs for sine? So if I look down here, my smallest value of sine is going to also be -1, and the highest value of sine will be +1. So the unit circle also gives us an idea of what sine and cosine should be at these different angles. And then it also shows us the domain and the range for these values. So now let's talk about something called a reference angle. A reference angle for any angle theta is the positive acute angle made by the terminal side of angle theta and the x-axis. So you guys notice here we have some diagrams, and as I read that description, you may have thought, why is it positive and why is it an acute angle, right? So we say that because um, say, for example, we're looking at this terminal side here, and we started at the x-axis and we go over. Well, that's going to be greater than 90 degrees. So the reference angle would be this other one formed down here that you guys see. It's kind of denoted theta prime, and it's going to be just this part of that formed by the x-axis and the terminal side. So we will always use the x-axis as our reference here. So we may be given some angle. It may be, it may go over 90 degrees and not be acute, but we should always be able to find an acute angle here by referencing the x-axis. So pretty much whatever that angle is, depending on whether it's on the side closest to 180 degrees or 360 degrees, we should be able to subtract, and I'll show you guys that here in a second. Okay, so a couple of things to remember with reference angles. Remember that we are always referencing to the x-axis. There's sometimes a common error that people use the y-axis, but the reference angle is always found with the terminal side and the x-axis. So here's our first example. We're going to find the reference angle for the angle 330 degrees. So I like to start with a picture because that kind of helps my brain figure out where we are. And I'm going to draw in my coordinate plane. Okay, so now that I've drawn that in, now I'm going to estimate where I think 330 degrees would be. And I'll do this by labeling my circle. So I know this is 0 degrees. This forms a 90-degree angle. This is 180 degrees, 270 degrees, and then 0 can actually be 360 degrees if I go all the way around, right? So now I know that 330 is going to be somewhere in here, and I can label it. Okay, so to find the reference angle, what I need to do is figure out what is the angle made with this terminal side, right? So this, my initial side before was the x-axis, and I came around this way. But what I want to find now is what is this angle formed between this terminal side and the x-axis. And if I know that that x-axis is sitting at 360 degrees, and I'm at 330, I could just subtract those two numbers and find the difference, so I end up at 30 degrees. So the reference angle for 330 degrees is 30 degrees. So now if I want to find what quadrant that terminal side is in, I just look at this as a coordinate plane, right? We said that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we count our quadrants counterclockwise. So it looks like that terminal angle will be in quadrant 4. And that's important because last time we talked about what we know about the quadrants and all of the coordinates in that quadrant. So just a quick review, we said that in quadrant 1, all coordinates are positive. In quadrant 2, only sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. And those correspond with the coordinates. So all standing for, we have a positive and a positive x and y coordinate, but we're talking about these in terms of cosine and sine. So cosine and sine are both positive. So now we want to find sine and cosine of that angle. Well, the really nice thing is that if I know what sine and cosine of 30 degrees are, then I should be able to find sine and cosine of 330 degrees. So cosine of 30 degrees, I can find that quickly. Maybe you already have it memorized. And I can give you guys a really cool trick to help you remember some of those. Of course, we can always derive them using right triangles and our knowledge of geometry to find these coordinates. However, sometimes we need to just know them off the top of our head. So here I've drawn, to the best of my ability, the 3 most important angles that we talk about, which are going to be 30, 45, and 60 degrees. Of course, all of these are important too, but if I want to find like the reference angle of 330 degrees, and I need to know what are sine and cosine of 30 degrees. Here is a really quick and easy way to remember that. So I have my unit circle here, and then what I'm going to do is just show you guys kind of a memorizing trick. And I know my coordinates are going to look like this. Okay, so I'm going to start from the top, and I'm going to go 1, 2, 3. And then on the top again, but in the second coordinate, I'm going to go 3, 2, 1. Okay, now you're wondering, what is she doing? Okay, so now I'm going to write these all as fractions. Now it should start looking like something. And I'm going to also write a square root over every number that's not 1. And then in the denominator of all of these, I'm going to write 2. And ta-da! We have just written down all of the sine and cosine values for 60, 45, and 30 degrees. And so if you know these, then when we have a reference angle that's referencing one of them, it's really quick and easy to find. So now all I have to do is go to 30 degrees and note which one is sine and which one is cosine. So we know that the first coordinate refers to cosine. So that's going to be square root of 3 over 2. Now, what I have to be careful about, and I just made that one mistake here because maybe I wanted to do it on purpose, or maybe I did it, right? I'm not just talking about the reference angle. I'm talking about the original angle. So I do have to remember where that angle was. So remember it was over here in quadrant 4, and we said that that's going to tell us the sign of cosine or sine. So that says that our cosine should be positive. So I'm going to leave this as positive square root of 3 over 2. And then for sine of 330 degrees, it is going to be 1/2. But since only cosine is positive in quadrant 4, this will be negative 1/2. Okay, one more time. So this time we're going to find the sine and cosine of this angle using reference angles, but this time we're just using radians, which is completely fine. We can do that. So I'll start again with my picture because that gives me a lot of information about my coordinate. Okay, so now I need to find where is 11/6. So I've got to switch my mind now to radians. So remember radians, 0, this one is pi halves, this one is pi, and then this is 3 pi over 2. So since 11 is greater than 6, I know it ends up somewhere in the improper fraction area, which will be below the x-axis. So if I look here as pi to 3 pi halves, that's obviously not big enough. So I know I'm going to end up somewhere here in quadrant 4. So 11 pi sixths will be here. So if I'm really good with my unit circle, I might go, it's split up into 6. So how do I split my unit circle into sections so that I can figure out what that is? So I would jump 30 degrees at a time. So I would come up here and say, okay, this is 1/6 or pi sixths. Then this one would be 2 pi out of 6, which is pi thirds. Then at 90 degrees, that one would be 3 pi over 6 or pi halves. Then we would have 4 pi over 6. And I'm going to leave these unsimplified just because I want you guys to see the counting process and where these come from. So now I've got to go under. So I'm going to jump 30 degrees at a time. So if this 180 degrees here was 6 pi over 6, now I'm at 7 pi over 6, 8 pi over 6. Right here at 270 degrees is 9 pi over 6. which is 3 pi halves. And now I know to split this one. So this would be 10 pi over 6. And there's 11 pi over 6. So we had to go almost all the way around. Okay, now what is the reference angle? So I want to figure out what is the angle formed here from my terminal side to the x-axis. And the answer would be, well, the x-axis is now 2 pi, or 360 degrees. So I can take 2 pi and subtract 11/6. I really need to simplify, or I need to get a common denominator. So I'm going to multiply this one by 6 over 6. That'll give me 12 pi over 12 minus 11 pi over 6, which will give me pi over 6. So there's my reference angle. So you can do that. You can subtract, based off of where you're looking on your x-axis. Is it closer to 180 or is it closer to 360? And you can do a little subtraction. All right, so the quadrant this time will be quadrant 4. So now sine and cosine. So sine, we can go in either order. I'll start with cosine of 11 pi over 6. And then we also need to find sine of 11 pi over 6. So it's almost the same question as before, or it really is, but we're just using radians instead of degrees. So if we go back again and I reference my unit circle, I notice that cosine of 30 degrees, aka pi 6, is going to be square root of 3 over 2. And it is also in quadrant 4, so cosine is positive. Sine of 11 pi 6 will be 1 over 2, and that will be negative since it's in quadrant 4. Okay, I'm giving you guys one to try, and I want to change this from 218 to, I believe, I want it to be 315. Okay, so you can pause here and try this on your own. Otherwise, I'm going to work this out. So maybe you started with drawing yourself a circle and figuring out where that angle is. So if I try to figure it out, I notice that 315 degrees will end up somewhere between 270 and 360. So it's kind of in this area again. And if you wanted to estimate where it is, it's kind of right in the middle, right? It is 45 degrees away from each side there. So 360, and it's 45 degrees away from 270. So here's 315. Now I need to figure out what the reference angle is. So even though to form that original angle, I went from 0 all the way around, right? The angle that I'm using to reference will be the one formed here from my terminal side, which is that blue line, to the x-axis. So that would be 360 minus 315, which will end up being 45 degrees. So that's my reference angle. What quadrant is this in? It is in quadrant 4. And now we need to find sine and cosine of 315 degrees. Okay, so what do we know about our reference angle, 45 degrees? I know that the cosine is square root of 2 over 2, and the sine is square root of 2 over 2. And therefore, now I just need to account for what quadrant that's in and which of these functions is positive. So since that's quadrant 4, only cosine is positive, meaning sine will be negative. So sine of 315 degrees will be square root of 2 over 2, and cosine of 315 degrees is square root of 2 over 2. All right, that is all for today. I hope that you guys had a good understanding of this. I want you to begin now looking at this in terms of relationships, reference angles, what are similarities, what are differences, and even if you start memorizing it, that's great. But you don't have to worry about memorizing like the whole thing. If you guys can get the hang of just knowing quadrant one, you should be able to find the rest of the functions for the unit circle. And then, of course, we also have the skills to be able to find these if we don't have them memorized by using special right triangles and our properties that we learned. So you guys can also do that. And then one more thing, just to solidify your understanding of the unit circle, I posted a discussion in Blackboard this week. You guys can just go to, I believe it's in the assignments folder, and just write in your own words what the unit circle is. And I will see you guys next time. Bye-bye.